When a number is added to its double and its triple, the sum is 714. Couldn't I write x plus 2x plus 3x equals 714 if x represents the number? Okay, so then what do we get there? 6x equals 714. What is it? Okay, so one of the numbers is 119. What's the other one? What? Oh, I thought you said 250. Okay. Susie, now percent. Okay, good. But you're not going to, some people just go crazy with percents, like they just start doing things with them. Just random things. They do. Like, oh, yep, I'm going to multiply this by 0.04, or I'm going to divide this by 0.04. No, let's think about it. Susie received a 4% salary increase. Aaron said something about 1.04, right?
No.
You did it?
Aaron graduated.
Oh my gosh. That was the first time I did it all year. So weird. I'm sorry.
That's Jolly Rancher, right?
It is. It's like a bag of Jolly Ranchers. Oh, Aiden.
Aaron, I was like...
You're like, where's the Aaron? Okay. He said something about 1.04, right? So you would multiply the old salary by 1.04 to get the new salary. Is that what you were saying? Okay, let's be careful here. Is this the old salary? No. This is the new salary. I don't know the old salary. Let's call the old salary X. All this allows us to do then is realize, okay, we're going to be dividing 37,120 by 1.04. Now, maybe I'm wrong. How many of you, just looking at the problem, quickly would have said to do that? To divide 37,000? Okay. You would have, okay. Because some people will do things like they'll multiply this by 0.04 and then they'll subtract it. Like, they're just not thinking. I know you really know what percentages mean, okay? Or they'll take this times 0.96. Those are not the same thing. All right, here, let's do it. What was the old salary? You know what is funny, Aiden? I don't know that I ever even really thought to myself that Aaron was your sibling. Do you know what I'm saying? Until, like, I just called you Aaron, and I never thought, like, in the first 3 weeks of school, like, oh yeah, Aaron, a couple years ago. I mean, I did think I had your sister 6 hour, but no, you didn't. But I just, it's weird. Weird. Okay. Oh, I'm sorry that I called you the wrong name. If it makes you feel better, I called my kids the wrong name. My parents did that to me, and I was like, how could you do that? Now I do it. Well, I have only 2 names to remember, but sometimes it's like, Andrew, Charlie, what are you? All right.
If you call me A-Mart, you can't go wrong.
Okay. A-Mart. That's true. Let's talk about number 3, and I'm going to tell you that number 3 shows up like probably 4 times this year, and then if you take calculus, we talk about it in calculus. So, and then 3 will be all we get through today. A square of side x inches is cut out of the corner of a 12 by 20 piece of cardboard. We actually kind of do this in...
This is like a math question that I did here.
we actually do this in algebra, okay? So I'm going to draw a piece of cardboard. I'm going to try to help you guys visualize what's happening here. Out of the corners, I'm going to do this dashed, well, that's where you're going to cut. Okay? And they're all x by x. Okay. They're little squares of x's. Okay. And sometimes I use if I cut these little squares out, it's almost like I have then like a big kind of sign. Does that make sense? Mm-hmm. Okay. If you fold where I'm tracing with my finger right now, what you would have is like an empty shirt back. Does that make sense? Okay, I want you to visualize if I come these out. Shirt box is like a shallow. Okay. All right. Like, if you got a shirt for Christmas, it might be a shirt box.
Oh, okay.
I guess that's what I see. All right. What? Okay, so this is where I'm folding then along these lines. So this is like what I'm shading in here is like the bottom of the box. Okay? We're going to try to make a volume equation. We're not going to do this algebraically. We are going to graph this. But volume of a box is length times width times height. Agreed? Okay. This box used to be 20 inches long, but then I cut off x on each side. So the length of the box is now 20 minus 2x. Just so you're understanding where this equation is going to come from. The width of the box, okay, so this piece used to be 12, but I cut off x on each side, so what would the width be? 12 minus 2x. And then the height is just x. So I'm not going to even make you multiply them out. I'm just going to have you put them in parentheses. Volume, V of x, equals length, 20 minus 2x, times width, 12 minus 2x, times height, x. Now, so far this chapter, we've been talking about domains. And we have talked all about domains of functions. We have not talked about domains with applications, because something could have a domain of all real numbers, but that wouldn't make sense for my problem. For instance, you can't have a negative dimension of a box. Agreed?
Right.
I want you to look at what's being subtracted here. What is the smallest value that x could be and still keep all of the dimensions positive? Oh, I should say, I said that incorrectly. What is the largest value that can be subtracted off, I guess, and still make the dimensions all positive? 6. Okay? That would be okay here. It would still be positive. 6 here would make it 0, so we're going to say x has to be bigger than 6. It could even be 6.01 if you want it.
Is that a soft bracket or a hard bracket or a parenthesis when you do that?
What's that?
When you're writing it in, like, x has to be greater than 6? Like,
Did I say greater than? I'm really having a rough first hour this morning. I've done a lot of mistakes. If it's greater than 6, it's a problem, is what I'm saying.
okay. But I'm wondering for when we write it out.
If it's greater than 6, it's a problem. Do you see what I'm saying? Because then it would be 12 minus something. Yeah.
Greater than 6, huh?
Then it's an issue. And I was saying x would have to be greater than 6. Really, x has to be, it has to stay less than 6. Okay, but it has to be positive, right? So we're going to say the domain is from 0 to 6.
Okay, so you use a parentheses instead of a bracket.
That's what your question was.
Yeah.
I would, just because then this would produce a dimension of 0, and we're not going to have a 0 dimension of a box either. Does that make sense?
Yeah.
Or if I did this,
Yeah.
does good?
Yeah.
Okay, now, last thing. Remember, all I'm going to look at is this, and we might have to adjust our window because the volume of the box might get pretty large. Would you go ahead and put this equation in your graphing calculator, please?
All right.
Now, if I were to multiply this out, it would be some kind of a cubing function. The only part I really care about is 0 to 6, and I'm looking for a maximum, so I might have to make my window big, okay, for my y's. So here, are you guys all okay with me going from 0 to 10, just a little bit beyond 6 so I can see it? And I'm guessing volume of a box is going to be bigger than 10. That's what's going to be graphed on the y-axis. I'm going to start with, I don't know, 100, and let's see what happens. Whoa! Not high enough. No, 100. I need to see the maximum. Do I see the maximum on the screen yet? No. Okay, so let's go, and now we're not increasing x max because our domain is 0 to 6. I want to increase y max. You want to do 400?
250.
Ooh, 400's big enough. Would you guys use the max keys to find the maximum? And just so I remembered what my window was, I'm going to do this. Are you seeing what I see, what I'm writing down? Okay. Now, let's answer the question, though. It says, use your graphing calculator to determine the dimensions of the box that will produce the maximum volume. So let's go back up here. X represents the height of the box, right? Okay. Because we're talking in inches here, I'm going to just round to the nearest inch. Are you good with that? Okay, so 2 inches by, oh, let's see, what's 20 minus 2 times 2? I'm trying to find the length now. Two times 2 is 4, 20 minus 4 is 16 inches. Why am I writing it up here? I don't know. Alright, and then 12 minus 2 times 2 is, let's see, 2 times 2 is 4, 12 minus 4 is 8 inches. So this is a pretty shallow box, because its height is only 2 inches. Remember? Shirt box. Shirt box. Okay.